friend, me Achan Upadhyaya would like to welcome you in my YouTube channel, Math Art Studio. Today I am going to use our names, students' names, your children's name, just to generalize some important mathematical concepts. And this type of approach will be continued in the days to come also. That is why please watch it every day. Thank you. Okay, dear friends, I will ask you one question. How many of you are together in your home? Can you tell me the name of your family members? Okay, some of the family might have these names. Let me write. Om is the name of one member. Ram is another. And Sita is the next. Shiva is another one. Avatar is the next one. And Himanshu. Seems that it's a big family. Okay. And I have already told that I am using the name of your family members and generalizing some useful and very important mathematical concept in a very interesting way. So for that one, let's count the number of alphabets in each name. In Om's name there are 2 alphabets. In Ram's name there are 3 alphabets. In Sita's name there are 4. In Shiva's name there are 5. In Avatar's there are 6. And in Himanshu there are 7. We have altogether 6 different people having different names with different number of alphabets. Now, we have already generalized that 2 is the prime number. Let me write P. 3 is also prime number. 4 is the composite number. 5 is another prime number. 6 is composite number. And 7 is again the prime numbers. And these prime and composite number were presented in the form of different patterns and generalized a kind of rule about them in our previous video. Today what we are going to do is we are exploring further properties of the numbers. For example, the number 2 can be arranged only in one way, either this or this. This is the same, it is rotated form is this and rotated is this, you know. Now the number 3 has additional property. It is a prime number, can be arranged this way, no doubt, but it also can be arranged in this way, so that the 3 dots make a triangle, you know. And they make a triangle, and this type of number may be more than this. That's why we are going to search for those type of numbers. For that one, let me write one important property, that is about the number 1. It is very strange in nature. So it can be written within a circle, becomes a circular number. It can be written within a triangle, becomes a triangular number. It can be written within a square, becomes a square number. Within a pentagon, becomes a pentagonal numbers, like that. That's why our first number with this triangular numbers is the number 1. This one is the triangular number. First triangular number is this. And let's see with 3 dots, this is another triangular number. First triangular number, second triangular number. Dots are arranged in that way. And in the third triangular number, what we have done? First triangular number, there was only 1 dot. We have added 2 and had become 3. And to this one, we have added 1 more dots in a straight line like this, so that they are arranged in the form of another triangle. This is next triangular number. It has the number 6 in it. And the next triangular number is this. The fourth triangular number is this. In this fourth triangular number, again we have added 1 more dot over there in another side. That is why we have altogether 10 numbers making a triangle like that. 10 ovals, 10 dots, 10 circular patterns arranged in the form of a triangle. And now the fifth triangular number has the number 15 in it, you know. First triangular number, second triangular number, third triangular number, fourth triangular number, and fifth triangular number in one sheet like this. So in the set of triangular numbers, we have the number 1, 3, 6, 10 and so on as the sequence of triangular numbers. So now let's go for the square number. The first square number is the number 1 because it has two identical factors, 1 into 1 like that. And previously also I described that 1 can be kept in any geometrical shape at the center and that represents that number. That's why this represents the square number 1. This is the first square number. And the second square number has 2 dots in each side and it has altogether 4 dots. 4 has two identical factors, 2 to the 4. This is a square number. It is another square number, the third square number, and this one has 9 dots. Next one is the 4 square number. In this square number there are 4 dots in each side and 4 4s are 16. It has two identical factors also and the dots are arranged in the form of a square. That's why it is a square number. Therefore we have 1 and 4 and 9, 16, etc., etc. are the sequence of a square number. Well, now we have another number which is the pentagonal number having 5 sides. The dots that can be arranged into 5 sides. Number 1 is the universal number. It is the neither prime nor composite number. It is a square number, it's a triangular number, now it is a pentagonal number. And our second pentagonal number is from the name of Shiva actually. It has 5 names there and these 5 dots can be arranged in the form of a pentagon this way. And the next one is the third pentagonal number. This third pentagonal number has another pentagon round about it having 2 sides common. And altogether it has 12 dots in it. The fourth pentagonal number has 3 pentagons in it and altogether it has 22 dots. Therefore, in the sequence of pentagonal numbers we have the number 1, number 5, number 12 and number 22 and so on. So this way we can find infinite pentagonal numbers in our number system. Okay dear friends, today we have explored some of the interesting patterns of numbers using our name and the number of alphabets in them. For example, in the name of Ram there were 3 alphabets and we arranged those number 3 by 3 dots in the form of a triangle. That is why the triangle can be associated with the person having the 3 alphabets in his or her name. That way, within your family members, how many alphabets are there in your family member's name, try to associate those number of alphabets with some kind of geometrical shapes and try to find how many such type of shape can be made in our number system.